Hello there, we're recording the review questions for Module 3 in Apologia Chemistry, 2nd edition.
Check it out, I got a chemistry shirt.
Oh my word.
I didn't even plan this.
That's so funny. Barium, cobalt,
and
nitrogen, bacon. All right, enough with the chemistry humor. So please read number 1 to us.
Okay. What is the difference between the continuous theory of matter and the discontinuous theory of matter?
Okay, so this is talking about science history, all right? So the continuous theory of matter was that if you had some substance, some piece of matter, it was the same all the way through, right? What is the discontinuous theory of matter?
In fact, it means, yes, that's true. Yes, you continue dividing it and making it smaller. Yeah, that's correct.
So who was the guy who came up with the discontinuous theory of matter a long time ago?
Democritus.
Democritus. He didn't call it the discontinuous theory of matter, but he said, I bet everything is actually made of really small things. If you could look at it closer and closer until we get to some basic building blocks beyond which we can't go, right? So he theorized that matter was made up of individual particles, which you could break down to a certain level beyond which they were coherent, as it were, right?
Right.
Okay, what's question number 2 tell us? Ask us, I mean.
What 2 laws were instrumental in the development of Dalton's atomic theory? What law did Dalton predict using his theory?
Okay, so the 2 laws that were important were what? Do you know? Let's find Dalton over here.
Well, I think one of them was the law.
So.
Okay. It was the law of definite proportions and the law of mass conservation.
Yeah. So the idea of proportions, right? So if 2 elements, if you look on page 82, we see the law of multiple proportions. If 2 elements combine to form different compounds, the ratio of masses of the second element that react with a fixed mass of the first element will be a simple whole number ratio. Also, the idea that you cannot destroy matter, that if you have a chemical reaction, you'll have the same amount of mass before as after, although it may have changed form. Okay, so the idea of conservation of mass, that matter couldn't be destroyed, only changed in form, and that these changes would happen proportionally, allowed Dalton to develop his ideas. And we're going to discuss Dalton's theory in a minute.
And the law he predicted was the law of multiple proportions.
First, we're going to do number 3, though. Can you go to number 3? Oh, I see. That is number 2. What law did he predict using his theory? Excuse me. So I misspoke, and I said that he used the law of multiple proportions, but it was the law of proportions, and then he predicted the law of multiple proportions. Does that make sense?
Yeah.
Okay. Please read number 3.
Write the law of mass conservation in your own words.
How would you say it?
Well, I'd say matter cannot be created nor destroyed. Simple.
Only
changed in form.
Right. We can't destroy or create matter. We can only change its form. So there are a variety of ways you could say it in your own words, or you could use the actual words in the book because those are the words you're supposed to have memorized. But you should be able to understand and comprehend the law. Okay. Number 4. Stop shaking the table then.
Right. List the 4 assumptions of Dalton's atomic theory.
So those are listed helpfully on page 83. Okay. They're listed. Number 1, please read it.
All elements are composed of small, indivisible particles called atoms.
Keep going.
Slightly incorrect because atoms can't.
We're going to discuss it in a moment. Can you please keep going? Number 2.
Number 2, all atoms of the same element have exactly the same properties. Number 3, atoms of different elements have different properties. Number 4, compounds are formed when atoms join together. Since atoms are indivisible, they can only join together in simple whole number ratios. Okay, so we've discovered that, in point of fact, atoms are divisible if you use a lot of power, but generally speaking, we can speak of them as indivisible. Number 2 is slightly modified because we've discovered that within certain elements we have isotopes,
which are the same element with slightly different atomic numbers, and they react slightly differently. But once we've identified the isotope, we can predict how it's going to react. Please stop shaking the table.
Sorry.
But the other laws, the other assumptions continue to stand.
How about number 5?
What is the difference between an atom and a molecule?
So how would you describe it, Martin?
Well, molecules are made of atoms.
That's right. So if we look at Dalton's assumption, we said that the first one says that there are indivisible particles, which we call atoms, right? Yeah. We said that they can be divisible, but for our purpose, we're not going to be splitting the atom in chemistry class, in high school chemistry, sorry. Most elements are formed of atoms. Some elements have a molecular form, like oxygen in nature is always a molecule of 2 oxygen atoms bonded together. But generally speaking, right, if we're talking about atoms, we're looking at the elemental form, okay? As I said, some of the same atoms of the same element will bond together to form a molecule. So a molecule doesn't have to be different atoms. A molecule can be atoms of the same type. They can both be oxygen atoms, as I mentioned. But a molecule will have more than one atom bonded together, okay?
What are the physical characteristics that distinguish metals from non-metals?
Okay, so these are physical characteristics or attributes which can be seen. Do you know what they are, Martin, or shall I tell you?
Tell me.
One is that metal can bend. Okay, non-metals are brittle, they break. One is that metal is shiny. Okay, metals have a luster or shine. And one is that metals conduct electricity, okay? So non-metals do not conduct electricity. Non-metals are not shiny, they do not have luster, and non-metals are not malleable, they are brittle, okay?
How can you determine whether an atom is a metal or a non-metal from the periodic chart?
Looking at the periodic chart, it actually is quite easy to determine. Let's find
it's
it.
labeled and everything.
Here it is. I'm going to hold it up for the camera. Okay. So looking at our periodic chart, we can see the jagged line. Also, our chart is, you're going to have to do that later, Jumpo. Our chart is helpfully keyed down here with these color codes. Not all periodic charts that you look at will look like this. Some will have more information, some will have less. They won't all have the same colors. But here, everything to the right of the jagged line, except for hydrogen, is a non-metal. And I mean, it's to the left of the jagged line, that's all I mean. Everything to the left of the jagged line, except for hydrogen, is a metal. So these are the non-metals. These are the metals, okay? So that's how you can read the periodic table of the elements. So if it's to the right of the, so the jagged line, if it's to the right of the jagged line, it's a non-metal. Unless it's hydrogen. If it's to the left of the jagged line, it's a metal unless it's hydrogen. Hydrogen is not a metal. Okay.
7. How can you 8. How can you experimentally determine whether a compound is ionic or covalent?
Okay, so this is experimentally, right? So we have to know what an ionic and a covalent compound are, okay? Ionic compounds are what?
Conductive to electricity.
Because they contain
metal.
They contain at least one metal element. So one of the atoms at least is a metal. So it'll be a metal and a non-metal, right?
Yes, or just metal.
Okay, how about covalent compounds?
That means that it's completely unconductive. I mean, there's no...
Covalent compounds can have an electrical charge,
right,
okay?
What I mean is
but
there's no
covalent compounds do not contain metal. That's the basic thing. Ionic compounds contain a metal. covalent compounds do not contain metals. So experimentally, how can we determine if it's ionic or covalent?
Well, there's two rather simple rules. If a compound contains at least one metal atom and at least one nonmetal atom, the compound is ionic. Number two, if a compound...
No, but you don't know. The question is, how can you what do we mean by experiment?
Oh, yes.
So
Okay.
let's say, for example, that we ran the experiment that we ran the other day, and I didn't say this is baking soda, and we actually put sugar in. So I could put salt in one water and sugar in the other water and have you put the electrical wires in. The salt mixture will bubble. The sugar mixture will not bubble. So experimentally, we could see that the salt mixture conducts electricity, whereas the sugar mixture does not conduct electricity. So without knowing that this is salt and this is sugar, we could determine that this is an ionic compound because it's conducting electricity, and this is not because it's not conducting electricity. So experimentally, you look to see if it can conduct electricity. If you can determine that, then you know it's an ionic compound. That's what they're asking in that question, okay? So the next question asks a different way.
How can you determine from the periodic chart whether a compound is ionic or covalent?
Okay, so if you know what it's made of,
Yes.
right? If you're given the chemical formula, you can look at it. So here's, for example, what's this, Martin? Is this going to be ionic or
That's
covalent?
ionic. That's salt.
Right, and so how do you know that it's
Well,
ionic?
it's nitrogen and chlorine, and one of those is
It's
metallic.
not, it's not nitrogen. Nitrogen is
Yeah, sodium and chlorine.
Mm-hmm.
Sodium.
So which one is the salt?
Sodium is
I
metallic.
mean, which one is the metal?
Sodium
Okay.
is metallic. Now the rules. If a compound contains at least one metal atom and at least one nonmetal atom, the compound is ionic. If
Right.
a compound is made up of solely nonmetal atoms, the compound is covalent.
Okay, so it has a metal in it, it's ionic. It doesn't have a metal in it, it's not ionic, it's covalent.
Mhm.
All right, so it's either ionic or not, and if it's not, it's covalent. All right.
10. Why do chemists use two different naming systems for compounds?
Okay, and that is because there are two different types of compounds. We have covalent compounds and ionic compounds. Now, they're not asking us what are the rules for naming them, but you do need to learn them. You will need to know, they'll later, as we go along, they'll give us just like the name and not the formula. So you have to know, is this ionic? Is this covalent? How do I figure out what it is? So that is why there's two different naming systems, because there are two different types of molecules, ionic and covalent. Okay, so that answers that question fully. They're not asking us to describe the methods, but you must learn them.
And the answers can be found on page 90 to 91.
Here, here. Thank you so much, Bacon Man. Bacon, move your hand. Chemistry is delicious.